All right, so what do you do with data like this? How can you do anything with noisy phase data like this? You're trying to do your main sub-alignment. You don't want it to take all day. It's just something you need to do. It's part of the sound system setup. It should only take a few minutes because you have 100 other things to do, right? Me 10 years ago, I would have looked at this and just thrown up my hands and said, well, this sucks and I don't know what to do. And then I just ignore it and go on with my life. Or worse, sometimes I would try to guess at values and I'd be like, I don't know, maybe like this looks better. Sure, let's go with that. Desperately trying to understand this. And I see some other people doing that too, and they sort of ignore all the other information that they have they could use to solve this problem and just focus on trying to like make this noisy data work somehow. So that's what I want to talk about today. How do you deal with these really challenging situations where there's lots of reflections indoor and you just have really challenging data? And I'm going to tell you the answer to this question right away, and then I'm going to go through a bunch of other information because what I want to do today is give you the fast answer to satisfy you, but then also I want to give you a bunch of little tools you can put in your toolbox that I've just learned over the years of talking to people and making mistakes. Okay, so some of you are thinking I'm going to say, use Subaligner, the product that I created and want more people to use. Yes, but I don't have almost, I think, any Martin audio speakers in Subaligner. So if you have a bunch of Martin audio speakers, I would be happy to travel to your location and spend a couple of days measuring all of them so I can put them into the app. There's nothing in Subaligner, there's nothing in Tracebook, and I've made other videos about where to get this data so you have clean data to reference to. And I couldn't go into anyone's shop. I was basically flying home, and then the next day I had to come and set up the sound system, and I didn't have any opportunity to get these measurements ahead of time. And I know I've made videos in the past about how you can download the GLL files. Now, I was really happy at first to see on the Martin Audio website that they have, number one, they have GLL files for all their speakers, even their subs, which a lot of people don't have. I don't know what the number two is. Anyway, it's great that they have all their GLL files, but watch what happens when we hit calculate. I don't know if this matters, but I'll just turn this off. It's going to open the balloon, and then we'll open the transfer function, and this is our phase data. So it's possible that I'm doing something wrong here, but I've found that this is actually pretty common for some reason. I don't know why this happens. I've asked manufacturers about it in the past and never gotten a response. So when I see something like this on someone's GLL file, I typically just give up. But I am going to show you a technique for how you can get some information out of this a little bit later. All of that is just sort of preamble to tell you that I know this is a challenging situation, one that we all run into a lot. Okay, but I told you I was going to tell you the answer right away, and then we'll get into all the tools and sort of like down into the weeds. The shortcut is to move your microphone and get better data. And I sort of hate that answer as well because I just want to like move quickly and just like put my microphone where I want the alignment position to be, get the data, get the alignment, and move on with my life. But if the data is not actionable, you have to get actionable data somehow. So here is the data that I ended up with once I moved my microphone to a better location. What was that better location? Well, you're maybe going to be surprised. It is up here. I went up into this little soffit. I don't know what you call this area. Up here, and I put my microphone as close as possible to the speakers, and it looked kind of like this and like this, right? A little bit dangerous for a microphone on a clip. Maybe I should have put a piece of gaff tape on there, but it was okay. And then I was able to get, much cleaner data here. Now you can see, now I can really do some work. This is actionable data. And now all my other tools, however you want to do this alignment, it's all going to be much easier. You're saying, hey, there's nobody sitting up there. This doesn't make any sense. And we'll talk about that a little bit later. But that's a short story. So if you don't want to watch the rest of this video, now you kind of have the answer, probably the main tool for getting better alignment. But let's go through some of this. So I talked about how these are not in subaligner yet, but getting those GLLs ahead of time can be really helpful. So let's look at those. So here's that GLL file exported from the GLL viewer and imported here into my audio analyzer. Again, doesn't seem very helpful, but one thing we can do is just look at the minimum phase version of this. And what that does is basically use the magnitude information here to construct a minimum phase version of the phase. So there's this little option up here that is minimum phase this, and I already have a saved version of that here. And here's what that phase looks like. So pretty different, right? Here's the old one, here's the new one. And then I imported this sub, and if I bypass this for a second, this subwoofer initially looked like this, has way too much high frequency information. So I guess this is just like native mode for this sub without any filters or anything. And so I just looked at the manufacturer recommended presets and I started adding some filters, and I think it's supposed to look like this. So this is the filters that the manufacturer recommends. This makes a lot more sense. And then I just played around with some delay and I was able to get an alignment like this. Now, I don't know if this is the alignment that the manufacturer intended, but it gets alignment through the crossover region and it looks pretty good. So at least I have something to go on here, right? This is kind of what I'm expecting. And what I would often do is then use these as targets. So now I can sort of look at these overlaid on my noisy data and see, oh, this is all noise and this is what it should look like here. And then here's my sub. Unfortunately, this did not get me to the solution. It's still just too noisy. I don't know really what to do with this. So let's talk about some other techniques. I'm going to mute these GLL files. And I'm going to mute this sub because I just want to show you something. A lot of audio analyzers have some kind of windowing or noise reduction functionality. And there's a feature in Crosslight, this audio analyzer, that's just called noise reduction. So that's going to vary from audio analyzer to audio analyzer, but I'll just show you what this one looks like. So if I unmute this, and hopefully that color is okay for you, you can just see, you know, the dark one here is the one I did noise reduction on. And it's much easier to read, right? Maybe I should change the color a little bit. But you can see that we still have this wrap here, and this is right in our crossover region here. This is really where we need critical information. You can see the coherence drops. We have this dip in the magnitude here. So, oof, this is going to be a problem. Probably not going to make it work with this particular microphone placement. So this is at head height at the alignment position that I wanted. So let's do two things at once. Let's change microphone positions and talk about another potential technique. So I'm going to mute this, go back over here. Let's go down to ground plane. So this is usually the first thing I'll try. If I have a bunch of noisy data and I'm in a hurry, I'll just take the mic, put it on the ground, usually like back up a few feet and then put it on the ground. Immediately, you can see this data is easier to read. So here, you know, we have about I don't know, 6 weird wraparounds that we're trying to read through, and then we put it on the ground and now we have less, right? So still not perfect, but now we're getting closer to what maybe is actionable data. Let's take a look at our sub. Okay, so I think if you had a little bit of patience, you could look at this and say, oh, okay, maybe I can do something with this. But let's talk about how we can make this even better. So we talked about location. Let's talk about, and I talked about noise reduction. And of course, I could show you that then the noise reduction on these traces makes everything even better. So let's mute this. Now we have higher quality data. Of course, adding noise reduction is going to be even better. So I could mute this and I'll just show you ground plane with noise reduction. Okay, now it seems like maybe we have actionable data. And so I could just attempt to run one of the auto solvers here in Crosslight. And then it looks like it gives me a result here. And then I could look at the magnitude. I could go on to like do some more verification steps. But now I have a better way to get data here. So that's noise reduction. That can be really helpful. What's another thing we can look at is some quick filtering can sometimes give us a big win here. So let's go back to our ground plane measurement. And let's look at the main and sub together. And what I'm going to do is put a low pass filter with a high Q on this. And what that's going to do is filter out all this high frequency energy. And so then we'll be more focused on what's just going on in the acoustic crossover region here in our time series data in the impulse response. And that should clean things up a little bit in the phase graph here. So notice that here I'm going to turn this filter on. Notice that I have 0 phase set here. So we're not changing the phase at all. All we're doing is filtering out the magnitude. So you'll see here, this is what that filter looks like. I can set the filter here. Maybe that'll make it more obvious. So now the filter's way up here. I'm bringing it down, and bringing it down, and bringing it down. Oh, you can see the filter down here as well. And now we get down here to the around where I know the crossover lives. And so now everything's cleaned up a bit more. And so maybe it's easier for us to read our phase data here. At least we don't have all of this noise up here, so that helps with our focus a little bit. And maybe now we can use our impulse response to help with this alignment. And so maybe now I would start playing around with the delay and seeing if I could get to a place where we have better alignment here. Okay, and so we see as we come into a better alignment here, it looks like the phase graph is getting a little bit better here as well. And then we could switch over and look at the combined magnitude as well. And there are, lots of different ways you could play around with those filters. I'm just showing you a low pass filter here, but we could also do something like a peak filter at the same frequency. And we could set it, to something high here, and, we're getting similar results. Okay, the next thing would be Wavelet. So I've seen a handful of audio analyzers now offering Wavelet transform. That's really great. So if you are using Crosslight, you can click on single wavelet. You want to first make sure that you have your cursors turned on here, and then you want to put that cursor at the location where you want the wavelet. So we can switch to single wavelet here. Now, just like every one of these techniques, if you have noisy data, then the wavelet transform is not going to save you. But again, it just helps you to focus on that area and maybe look at the data in a different way. So for example, if I go back here to my head height measurement, you'll see this wavelet transform is really a mess here. And so if I tried to align these peaks, it would probably be a mess. But once we clean up the data, even just a little bit, now our wavelet transform becomes a lot more helpful here. And we could potentially try one of these auto solvers here again and see what it tells us. So it's run the auto solver here, and it looks like this alignment's a little bit better. We can back off this reference here to make it a little bit easier to read. Yeah, that looks pretty good. And then you can go on and do more verification checks. So that's just another way to observe the data. And then there's a handful of just other ways that help to focus. So we have coherence blanking, we have magnitude threshold blanking here. So as I scale this up, I can really get rid of everything I don't need to look at. And then I can also zoom in on the graph here and say, hey, I really just need to focus in this area right here. So let me zoom way in. This can also be really dangerous, right? Like you're totally ignoring everything else. But sometimes just changing the way the data is displayed can really help us out, okay? I don't know if there's anything else about focus that I wanted to tell you. Well, I guess just adjusting the size of these graphs as well. Normally the graph's like this, but hey, like if I want to look at this better, maybe I make this graph really big, then I can zoom in here and see what's going on here, that kind of stuff. But one other thing I forgot to put on the list here is just, I guess, isolating different elements. So I forgot to even mention that I didn't even try this alignment with the entire sound system on. I knew it was going to be challenging enough that I wasn't going to try with both on. So I soloed this right side first. And first I just said, okay, let me see if I can get this guy aligned with this guy. And it shouldn't be too hard because they're basically in the same location. And of course, then the sound bounces all around the room and it becomes hard. But what you can do to further isolate here is say, okay, what if I just solo this element? Here, let me zoom in here. What I did is, and you know, this is not always available, but luckily they had some granular control here. So I was able to solo this element and this element. And I have that over here. So this is just soloing one element. And you know, the data cleaned up a little bit. You know, we should be able to get, I don't want to necessarily say better alignment here, but if you're really struggling to get actionable data and you know, everything else you've tried is not working and you can't get the microphone in a better location, then maybe just turning on one element of that array will help you. Okay, so as I mentioned, the end of the story was that I, you know, took my microphone up, got really close, and then I was basically able to see what is the alignment that needs to happen here. So let's go and take a look at that data. Let's reset the reference here. In fact, let's just try an auto alignment here. Let's optimize this by time. And here we go. So it attempts to give us matching phase slopes here. So I say, okay, maybe we need a polarity inversion. Now you see, we only have 1 millisecond of delay here. And this may have been the alignment that the manufacturer intended, but you can see that we're really only aligned at one frequency. If you guys have seen my other videos, you know that as long as you can get aligned at one frequency, that is a great starting point because then you can sort of tilt the entire phase trace around like a teeter-totter around that single point. So we are currently at 89 hertz here at this red cursor. So all we need to know is what is half wavelength, half a period at 89 hertz. So 500 divided by 89 gives us 5.62. So that's something like 6.6 milliseconds. And now we can take out that polarity inversion. And now we see what to my eyes is a better alignment. And we could go on to do some further checks. Maybe we take a look at the magnitude. Maybe we look at the sum here. Maybe we don't like that we're missing some dB here. So now we can play around with it. But now this is just the fine tuning, right? Now we've come very far since our initial data that we had that looked like this, right? And then the last thing that I did, once I had this alignment where I knew, okay, when I'm close and I just have two elements that are basically equidistant from the microphone, I know that I need 6.625 milliseconds of delay. Let's see if there's any delay in the other channel. No. Okay, so I need 6.625 milliseconds to delay, maybe a little bit more if I want to try to pick up some more summation here. That's my preset now. Now I need to modify that preset with any distance offset. Well, not really any distance offset here, but if you want to be picky, and sometimes I like to be picky, then, you know, the center of this array is actually right here. And so if we measure from the center of this array to our alignment position and the center of this array to our alignment position, there is a minor distance offset. So I took this alignment, 6.625 milliseconds, and ended up modifying that by a little more than a millisecond. And I'll tell you guys, this didn't all happen in one day. I came in here on the first day, I was in a hurry, I looked at that original data and I was like, I don't have time for this. You know, I'm just like you guys, I don't have all day to spend on subalignment. Luckily, I was in there for multiple days, so when I came back the next day, I said, you know what? I know that somebody like Francisco Monteiro, the creator of Crosslight, would tell me to get better data. So what can I do here to get better data? Hey, I'm going to take my microphone. I have a wireless microphone. I can take it anywhere. Let me see if I can take it up into those speakers. So, you know, sorry this video was so long, but it's one of those times where I just was working through this so much that I realized that there's a lot you can do. And when I was first starting out, I just wasn't familiar with all these things. So let me just try to summarize a little bit, and I'll open up this thing to make it easier on myself. What's the number one thing that's going to get you the most bang for the buck when you are trying to get actionable data? It's probably microphone position. One thing we didn't explore here is using different kinds of microphones. You can use directional microphones to help focus in on a certain source. I haven't experimented with that, but there are videos on YouTube of Mauricio Ramirez experimenting with different kinds of microphones and showing how you can clean up the data. So that would be another thing to explore. Most audio analyzers have some kind of noise reduction features that you can play with. You can run your data through some different filters to try to focus on some different areas. Maybe try wavelet analysis. And then there are different ways you can focus in, just zooming in on the graph, manipulating it, and then there's like magnitude and coherence blinking and things like that. And then the last thing that I talked about was just trying to solo different sources. So instead of trying the entire array, is it easier to look at a single source? Sometimes that's not the case because the entire array actually focuses the energy and keeps it off the walls. And if you go to a single source, maybe it's more omnidirectional. Okay, I hope this was helpful. Let me know what questions it brought up for you. You can comment on this video and we'll keep the conversation going. All right, thank you.